Hello, everyone. My name is Eleni Papadonikolaki. I'm a lecturer in Building Information Modeling and Management at UCL, University College London. So we're very close by. I'm based in the Bartlett School of Construction and Project Management. So you would wonder what it has to do with 3D repo and the British information modeling. So today I will be speaking about the AEC Delta project. This is a project, This is a AEC Delta Mobility project. It's a project funded by the Innovate UK. So I'll spend a couple of minutes talking about the problem that we are addressing and also introduce Speckle. Speckle is an open source platform which is created by Dimitris Stefanescu, which is right here. So while he was doing his PhD, also at UCL Bartlett Architecture. And then I will share some project updates and also some updates with regards to Speckle. So the AEC Mobility, Delta Mobility project is an 18-month project, so we're around in the middle at the moment. And it's funded as part of the Innovate UK industrial strategy. So it's very much important about streamlining the way that we're doing things in construction, and the vision of this competition. The industrial strategy challenge fund was to change how we're doing things and how we can make things more efficient. The project leader is Budo Happold Engineering. We are the knowledge partners as UCL Bartlett School of Construction and Project Management. And of course, 3D Repo, Joseph is leading the project from the platform of 3D Repo, as well as Rombak Sersa. And there are a number of other organizations who have been helping us with outlining the requirements and how we can take this project to the next level. So what we are delivering open delta specifications, essentially how to implement deltas. I will explain shortly what this is. Open REST API specification, essentially for interacting with different software, and also open source reference implementation. So as you see, the open type of thing is very much emphasized in this project. So we're trying to do things differently, following an open innovation paradigm. All the information about our project is available on github.com AEC Deltas, where we have some requirements, and we want to hear as much as possible from users in the industry on how we can make this project more relevant. And the main idea is that we want to discuss about exchanging information in construction, in the AEC industry, not through file-based or model-based approach, which is essentially what we're doing now. Hey, here's my file, take it, or here's my model, take it. But discussing more about deltas, so essentially differences between files. Traditionally, we have been sharing entire models, which make collaboration and coordination very challenging. And also tracking changes is very problematic. So the concept of delta essentially is to understanding what's differences, so looking at the differences between different files, and essentially minimizing the data payloads and making this transfer of information more efficient. So for example, you have Alice sharing some files, creating a stream when some files are created. So stream is a main concept. Creating a stream, share it to Bernard, and then whenever the new actor is making a change, then another stream is created. And this goes on. So we can have in the design process different streams created depending on changes and specific parts of the model. And this project is based, as I said before, in an open innovation paradigm. So we're using different open source platforms. Speckle, that I will be speaking more today about, is one of them. Also the BOM platform from Budo Happold Engineering, as well as 3D Repo integration. And this presentation today is very much a Speckle way of a Speckle view of the AEC Deltas project. Essentially, we want to make sure that whenever, for example, we can have from Grasshopper, and you saw some things before from Helen on Grasshopper, changes through Rhino and then Speckle connected to 3D repo. So far, we have finished the stage of understanding the user requirements, defining different users, and also it's very important to define what diff is, what the different changes, how they can be defined, for example, at object level, but also comparing different properties between the entities of the project, of the files, as well as a Delta specification. So information is available on GitHub as well. And we're doing initial implementations across these different platforms. So Speckle sits very much in the center of collaborating with different software, such as Rhino. We had presentations before about connecting Rhino with different software and Grasshopper. The main concepts of Speckle are data streams that I will be speaking today, the next 5 minutes, hopefully, objects and clients. So data streams are essentially a flat collection of objects. Essentially, it can tell us what sort of versions we have and how we are defining permissions and allows querying also. Objects also include some geometry, so it's extensible basic geometric types that can support different object models. Some examples like IFC bone. And clients essentially are the connections between these objects, the connections that actually help us understand what's going on and how we are defining these different streams from where information is shared across. And whenever, for example, we are designing a parametric form, we heard before about algorithmic design, typically we have many different components being designed, and this is just an example. So Grasshopper is a visual programming language, as you may know, but it's good to understand how we go from one form to the other when we are designing a building. And whenever we have a data flow, a process like that, we typically have many different actors involved in contributing to the design. So our next step with Speckle is to understand how we can essentially understand more these flows, data flows from one actor to the other, keeping in mind that all of them, they're using different tools to do their job. So it could be Grasshopper, could be Excel, inputting information in many, many different ways in the models that we are sharing. And at the same time, they're communicating in, again, many multivariable ways, and they're using also not only human actors, but also non-human actors, because we have software sometimes doing the work for us. So all this complexity, we're trying to understand with Speckle how to model, how to represent communication flows when we are designing. And the idea is very simple. The idea is the idea of a network. A network is whatever contains nodes and arrows that connect these nodes. And there are many approaches in the past and many different visualizations of how we can essentially represent the relation between what we're doing in, for example, different software or with different tools and the information that we are sharing. So with Speckle, it's very easy to create diagrams like that. So accessible through the Speckle admin, essentially, we can get a list of the source of streams and the receivers of streams. So we can have a map, we can create a map of how information flows within this design routine. For example, in any project, we can have different streams created. We have user A, user B. User A creates a stream, which is sent to user B, and then after editing or manipulating or adding a new geometry, this would be a new stream that goes back to user A. So this is essentially a triple, so a triple between user A, user B, and user C. It could go back to the same user, but it could go to a different user. So with this spectral metagraph, essentially what we're trying to do is to visualize the different streams, so the data flows as you will see here, rectangles, so they're the nodes, the streams, they're the nodes. Think of them as activities, as tasks, as new information about a project generated, and the arrows are the pipes, or they're connecting lines which are connecting the different streams to one to the other to the project. So every project has a lot of streams connected. And they are color-coded because we can have networks which are dynamic. So dynamic networks means that they evolve over time. So the different colors here mean that these streams were generated in different parts of the design process because they're time-stamped. And with pink, we can visualize, for example, where these streams are generated and where they go. So think of them as actors that are generating new information in these streams. So just a quick video, I hope it will play later, next slide, don't worry, of actually using in a project, in a workshop. So as you see, okay. So as you see, there is a timeliner in the tool, and you can choose to represent different stages of these data flows from the start to the beginning of the project. And then from each node, you can actually have a look at the exact stream which is exchanged and understand about the accountability, about the authorship, and who is doing what in a project. This diagram is represented in a specific way. You can also change how the graph is represented. So typically, it's a linear graph. And yeah, I think we can go to the next slide. So the graph at the moment that we are working, as I said, it's available through Speckle Admin. Information is through GitHub, SpeckleWorks, Speckle Admin. So you can play with that. And we'd like to hear from you after the presentations, during the drinks, on how we can work more on this and how to improve it. And actually, because we are knowledge partners in this project and we come from academia, we are always very hungry for data, using real cases to test our ideas and help through our tools and our knowledge the industry. The same goes with AEC Deltas. So AEC Deltas is an ongoing project. As I mentioned before, we are also mid-stage in the project. We do need cases, we do need to check, and you have good models to develop further our platforms. So thank you very much.